Why crop combination analysis is so important? Now, if let's say I am a farmer, I have 1 hectare of land with me. If I want to grow crops in that land parcel, how many crops should I select? How much area should be assigned to each of the crop? Now these are all the questions that exist, and these methods that we understand for crop combination analysis helps us to answer this question. But before we move towards crop combination, let's have a quick look on the urban area. In the urban area, what happens is there is functional specialization. When I say functional specialization, this term means it's very relative. If I say place A produces good glass, is a good center for glass industry, place B is a good center for, let's say, pottery industry. Now this is functional in nature. Probably place B could also have glass industry, but since A have an additional advantage to it, the functional specialization shifts towards A and B does not reap the benefit of the same. But that does not apply to the case of crop combination. In the case of crop combination, what happens? In the case of crop combination, it is specific to one particular area. So it is not interdependent or it's not relative, it's absolute. So the cropping pattern of my land parcel would be independent and cropping pattern of your land parcel would be totally independent. On what factors it would be based? Definitely the soil, the water availability, and all related factors required for crop production. So it is absolute in nature. It does not have the functional specialization requirement that exists. Now, when I say crop combination, ideally if I want to grow 5 crops, for example, I can divide my land parcel simply into 5 distinct sets, and so if I have 100 hectares, I can have 20 hectares of 5 different crops that can be grown. But this is a hypothetical arrangement. What happens in real world is something different. So let's understand this weaver's method with a very simple example. I have percentage of various crops. I have 7 different crops, the 8 different crops that I have taken here, and on the actual land, on my land parcel here, I see that 35% of the cropped area is bajra, 23% for example is jowar, 15% is cotton, so on and so forth. But if I take the real ground example, if I take the real division, I can say this 100 hectares has to be divided into 8. So 100 divided by 8, 50 divided by 4, 25 divided by 2, so 12.5 is the proportion of land hectare that I can assign to each of the crop. But rather than those values, this is the actual value that is visualized in the farm. Now, what is the most viable solution? I need to find this out. If I need to find out the most viable solution, I need to find a method of crop combination which gives significant share to the proportion of the total cropped area. What does this mean? It means that I would have the hypothetical values with me. So, in the first case, what I do is I take an example of monoculture. Monoculture means just one crop. So assume that I crop only bajra, no other crop. So how would I determine my crop combination analysis in that scenario? And in the second case, I take 2 crops. I give hypothetically 50-50% land area to both of those, and then I say that what is the production outcome, and I have certain values. Now once I have the values for all these steps that we would understand in a while, I find out the values which is the least value. The value that comes as a least value would be the number of the crops that are most suitable for this region. So we would proceed with this example to understand this weaver's method better. So under this weaver's method, we have sigma square as it is connoted as, which is the crop combination analysis. It is given as summation of xi minus x bar square divided by n. N is the total number of crops. Now, note, in the weaver's method, we take n, which is the total number of crops. This is not taken into account in Thomas method, which we would understand later. Xi is the real proportion of the land under cultivation, and x bar is the hypothetical proportion. Okay, so when I say the hypothetical proportion, I would first take an example of a monoculture. So when I take an example of monoculture, what happens is, in this scenario, I have bajra only as my monoculture crop. So my hypothetical value is 100. I have just one crop. I take it as 100. My observed value for bajra is 35.9. So I find the difference and the summation of the difference. Now here no summation, just one crop. So the difference I would take directly. My difference comes up as minus 64.1. Observed value minus the hypothetical value. So this is the observed value, this is the hypothetical value. I take the difference is 64.1. I square this difference. As we can see, it's the summation of the square. So 64.1 square. So it is 4108.81. And then I divide this value by the total number of crops. So since it's a hypothetical assumption of monoculture, I am considering just one crop. So I divide 4108.81 divided by 1, and my answer comes as 4108.81. This is the case with monoculture, just bajra taken into account. Now in the same example, I move with a twin culture or a diculture approach where I take two crops, which is bajra and jowar. So my hypothetical values are 50 and 50. My observed value are 35.9 and 23.7. I take the difference, which is 14, which is now from 50, I am taking 14.1. So minus 14.1 and minus 26.3 as the value. I square these values. So the values come as 198.81 and 691.63. Now I sum up these values. So the sum of the values come up as 890.5. Now since I have taken two crops into account, I would divide this value by 2. So my value here would be 445.25. Clear? Now I move forward. I take 3 crops. So the same problem is being solved as of now. So I am now considering 3 crops, bajra, jowar and cotton. So I give a weightage of 33.3, 33.3 and 33.3 to all these crops. Okay, when I give this weightage, I take the difference. So my values are 35.9, 23.7 and 15.2. Now I take the difference as plus 2.6. The next difference is minus 9.6 and 18.1. I square these differences, which is 6.76, 92.16 and then 327.61. I add these as 426.53. I divided by the total number of crops I have taken. So 3 crops taken here, I divided by 3. I get a value of 142.18. Now this is when there were 3 crops. Now what I do is, I take 4 crops. So I remove this value, I take 4 crops. Now 4 crops become very easy. 25, 25, 25. So my hypothetical values are 25, 25, 25 and 25. My actual values are 35.9, 23.7, 15.2 and 11.4. Now I take the difference again. So those come as 10.9 minus 1.3. Then we have minus 9.8 and minus 13.6. I square these values as 106.81, 1.69, 96.04 and 184.94. I add these values. I add all the d square. So summation of d square is 401.50 divided by 4, which lands up to 100.38. So this is my value with 4 crops. Now I continue the same process with 5 crops, 6 crops, 7 crop and 8 crop. My values with 5 crops, let's say, comes to be 169.5. You can calculate it further. Values for 6 crop come around 131.79. With 8 crops come around 136.05, and with 7 crops come as 133.71. Now, as I said, what we take is the least value. So least value was with which crop? 4 crop. So I can say this parcel of land works well with 4 crops. So on this parcel of land, if I am planning to have a cultivation, what would be the ideal way or ideal number of crops that should be grown, and in what combination? So 4 crops with the combination of those crops which have been cropped in the highest percentage. So I forgot to mention that in the beginning. The idea here is we arrange the crops in the descending order. So highest proportion cropped area at the first and lowest proportion cropped area at the last. So this is again important, but this was not the end. Weaver's method was definitely too good, but it brought about a lot of criticism with it. The first criticism is it ignores the deviation sign. As we took the difference of the square of the difference, so the difference sometimes was coming negative, sometimes was coming positive, but Weaver ignored it because he took the square of the deviation. So that was one of the drawbacks. And the next important drawback that was pointed out was that for higher number of crops or the functions, the theoretical percentage goes down, and so the deviations that occur towards the end are highly underestimated. So there is no chance that if we take a huge number of crops, the proportion would go up significantly, as was the case with monoculture. We have seen the values were significantly higher, but as we moved with increasing number of crops, the values declined significantly. So towards the end, if the number of crops are too much, there is theoretical percentage which reduces, and so the deviation by the last ones are usually underestimated. So that was again one of the drawbacks. So with all these drawbacks, there were numerous other models that were suggested, including one suggested by Thomas, where Thomas said that since we are dividing the crops with the monoculture approach, a biculture approach, we are saying hypothetically it should be 100, hypothetically it should be 50-50, but we were considered only 100 and forgot the remaining ones. That should not be the case. If the first crop is considered as 100, the remaining should be considered as 0, and the d square should be calculated in proportion to it, which was a concept which was ignored by Weaver, accounted by Thomas, and therefore this was again one of the drawbacks. A next significant drawback was cited by Rafiullah, and Rafiullah said that this was as a modification of the Weaver's model, because if we are trying to apply the same concept to the functional classification of the towns, we would have to have a difference of the deviation, the positive and the negative deviations, and then we should take the square of those into account, the summation of those into account. So that was some of the major drawbacks which were cited with the Weaver's model, and therefore revised versions by Thomas and Rafiullah were brought into account. So Weaver's method was criticized by Thomas and Rafiullah, and there were changes that were brought in the crop combination method which was laid down by Weaver. As we already understood, in the Weaver's classification, what is very important is the assignment. So when I say the hypothetical distribution, it should be equal. If there are 4 crops, it should be 1/4 account for each of the crop. But in the real world, that does not happen. And how do we identify if I am bringing in more and more crops, what would be the best method? So Weaver laid down a method which was criticized by Thomas, because Thomas said that if we are taking a hypothetical value for one of the crops, we need to take the hypothetical value for other crops as well into account. For example, if I say this is a monoculture, only one crop should be grown, and I say bajra accounts for 100%, that means all other crops should account for 0, 0, 0, 0, 0 and 0 but this was not taken into account by Weaver. Now what Thomas did was he took the differences. So difference here was 64.1. Here the difference was 23.7, 15.2, 11.4, the same values which were repeated because there was no significant difference as the other crops proportion was 0, and the difference remained the same because any number minus 0 would give you 0. Now what he took was the square. So d square, the square of the difference, so 14108.81, then we have 561.64, then there is 231.04, and so on and so forth. And finally he said add up all these differences. So adding up all these differences we get 5067.55. Now this was the case with monoculture. Note, Thomas said that since now in this hypothetical method we are taking into account all the crops in the same go, we don't need to divide it by n, that is the number of crops. So if it was monoculture, I would divide it by 1. If it was 2 crops, I would divide it by 2. If there were 8 crops, I would divide this d square by n, okay, because I was ignoring the other crops. I was not simply taking them into account in the Weaver method. But that's not in the Thomas method. So in the Thomas method, we take into account all the crops, and therefore we need not to divide it by n, the number of crops. As simple as that. So if I take 2 crops into account as per Thomas method, so I take 2 crops here. My crop percentage are 50 and 50. So for all other crops, I would assign the values as 0. Okay, now I would take the difference here as 14.1, 26.3, and all the remaining values would remain the same as given because they are subtracted from 0. So only first 2 values would be subtracted from 50, but I am not ignoring all those values. In Weaver's method, we ignored all these values. Here we would be taking the d square of all the remaining values as well. Now I take the d square for all of those, so 198.81, 691.69 and so on. I add up all these values, it comes as 1287.55. So this is when you have 2 crops. Now I move to 3 crops. For the 3 crops, my hypothetical value are 33.3, then 33.3 and 33.3. So I take the difference here, and for the remaining it remains 0% of the land that was given. So the remaining would remain as it was given in the question. So I subtract them with 0, values remain the same. For this values I take the difference, so 2.57, 9.63 is the difference between the two, and then we have 18.13. Then I take the square of those as 6.6, 92.974 and so on, and I add all the differences which are there. Now when I add the differences, so my sigma square is summation of d square, and this value comes as 594.05. So this is when there were 3 crops. If there was 4 crops, what I would do? I would divide this as 25, 25, 25 and 25, and the remaining as 0. Then I would again take the differences between these, 35.9 minus 25, 23.7 minus 25, 15.2 minus 25, and then I would square the values, the differences that would come here. So 25 minus 11.4 and then 4.7 square. So all the values, the difference and the square, and then I add up all these and I get the answer again. So I do the same method, but important to note, the findings in the Thomas method and the Weaver method were very close by. Again in the Thomas method, the value of the index which has the least number of crops would be the answer. So here again 4 crops come as the answer. We can calculate it with 5 crops. So I can take this as share as 20, 20, 20, 20 and divide it into 5 crops, and rest of those I can mark as 0, 0. I can take the value for d and d square and calculate it further. But my lowest value would come with 4 crops, and therefore ideally in this parcel of land, this 4 crop combination would be the perfect crop combination. That means on this parcel of land, bajra, jowar, cotton and wheat grows best. So this was what was laid down under Thomas method. But Rafiullah cited that this is not enough. There needs to be a further modification. And what modification he suggested? He suggested that I need to take the deviations which are positive and the deviations which are negative separately. I need to square those deviations separately and then subtract those. And that was the Rafiullah's idea for the functional classification of towns. As we mentioned in the beginning, functional classification of town is a relative concept. One town can specialize in one thing and supersede from the other town only when there can be specializations in both the town. But if first town wants to supersede the second town, there needs to be a functional classification where I say that this town is much better in terms of glass industry than the previous town, where glass and pottery both flourish. So therefore Rafiullah devised this method. So what he did was, same in the previous example as we did, the values, the differences were taken. So what was the differences cited? So some of the differences were negative values, the other differences were positive values. So when the difference was negative, all the square of those negative differences were taken separately and the square of the positive differences were taken separately. Okay, and in the Rafiullah method, the summation of the differences which were positive were taken first, and then from that we would subtract the negative differences, the square of the differences which were negative, divided by the total number of crops, the square of those. And important to note, in the Rafiullah's modified method, it was not the least value that would come up as the correct combination. Here, the maximum value is considered as a critical combination. So, it would be the maximum value as a critical combination, not the least value as in the case of the Weaver method and the Thomas method. So here we understand the various combination analysis, why combination analysis are important, and how in agriculture as well as town these combination analysis play an important role, and they give farmers an insight about how many crops and which crops could be perfectly grown in that land parcel, and this would further boost the process of agricultural productivity. We would cover many more interesting classes on statistics and combinational analysis in our further lectures. Stay tuned. Have a wonderful day ahead.